Hello and welcome to this learning video. Here we're going to discuss about the third property of Laplace transform. So let us see what this third property is all about. So third property says if Laplace transform of f of t is f of s, then prove that Laplace transform of f of a t is equal to 1 by a into f of s by a, and hence you have to find out this. Okay, so let us start with the given thing. So this is the definition, so we can start with the definition. So here you can write by the definition of Laplace transform, by the definition of Laplace transform, we have what we have by the definition of Laplace transform. Laplace transform of f of t is equal to integration 0 to infinity e to the power minus st into f of t dt, and we are given that this is f of s. We actually know it, f of s. Okay, so this is the definition. What we want Laplace transform of f of a t. So you can directly write it as like Laplace transform of f of a t. So what we are doing it? We are scaling. Okay, we are scaling t by factor a. So Laplace transform of f of a t is integration 0 to infinity e to the power minus s. What is t? T is replaced by, no, only f of t, sorry. So only f of t is replaced by f of a t dt. Simple. Okay, now we can't solve this integration of such functions, so we have to make use of substitution, right? So here you can write, put at is equal to x. So what is t? Implies implies t is equal to x by a, right? T is equal to x by a. Therefore dt is equal to dx by a. And limits are unchanged. Why? Because if you write like this, this is the limits of t are 0 and infinity. What is the limit of x? When I put x is equal to what? When I put t is equal to 0, x is equal to 0. And when I put t is equal to infinity, x is equal to infinity. So limits are unchanged, right? So this implies, say this is to be, say this is to be 1 and say this is to be 2. Okay, so 2 implies, what is it? Laplace transform of f of a t. Now one remark I would like to make, don't change over here. Okay, we are changing, we are making substitution for solving integration. So please make it as it is, write it as it is, because most of the time what student or what learners do, they do the substitution over here also, which is not required actually. We are making the substitution for the sake of integration, okay, to get solved. This is equal to limits unchanged 0 to infinity e to the power minus s. What is t? T is x by a into f of x. What is dt? Dt is dx by a. So you can take 1 by a outside, right? And we remain with integration 0 to infinity e to the power minus of s by a into x into f of x dx. Okay, don't bother about the things written in terms of x. Now you look at this first equation and this equation. Integration 0 to infinity e to the power something f of x dx. Okay, so if you look at this equation and this equation, what you can do? You can certainly write this integration as, if it is like s, you write f of s. If it is s by a, you write f of s by a. From where we are writing this? By 1. Okay. Therefore, Laplace transform of f of at is 1 by a into f of s by a. Clear? So this proves the property. What we are doing here, we have the function f of t and we are changing the scale of the function by multiplying it by a factor a. That's why this property is called as, this property number 3 is called as change of scale property. Change of scale property. Okay. Now this is just the first part. Now we have to prove the second part. What does second part says? Find out Laplace transform of cos 3t by using this. Okay. So I have to rub this now. I hope this is clear to you, the proof that we are doing it. Okay, now we have to do the second part. So for the second part, first of all we have to find out Laplace transform of f of t. So f of t is equal to, what is it? Cos t. This is f of at. Okay, we want f of t first of all. So f of t is equal to cos t. This implies Laplace transform of cos t. What is Laplace transform of cos t? Laplace transform of cos t is s upon s square plus a square. A is 1. Sorry, s upon s square plus 1. Okay. Now, after this, you just see here, we have to find out Laplace transform of cos 3t. So, by the change of scale property, you can write here one sentence, simple one, by change of scale, by change of scale property, Laplace transform of cos 3t is equal to, what is it? Laplace transform of cos 3t. So if you compare with this change of scale property, a is 3. So it is 1 by 3 into f of s by a. So I am writing this s upon, what is it? F of s by a. So we have f of s, this is my f of s. So you can write s upon s square plus 1 and replace s by a. A is 3. Okay, so this is 1 by 3 into s by 3 upon s by 3 whole square plus 1. So this is 1 by 3. This can be written as s upon 3 into, what is it? This is s square by 9 plus 1. Okay, so this is s upon, what is it? 3 3s are 9. Take LCM of this. So this is s square plus 9 by 9. So this 9 get cancelled. So we remain with s upon s square plus 9. Okay, so this is my Laplace transform of cos 3t. Very simple. And we actually know what is Laplace transform of cos 3t? S upon s square plus 3 square. So the answer is also verified because we have seen the elementary Laplace transform. Simple. So in this way you can solve the problems. So let me give you one problem as try this. So I am giving you a tricky question. tricky, try this. So tricky try this says find Laplace transform of f of t by a. Find Laplace transform of this. This is the problem for you. Tricky try this. Find Laplace transform of t by a. We have already seen Laplace transform of a t. This is f of 1 by a into t, that is t by a. Okay, so that is the question that you can solve, and try to write down its answer in the comment section so that I can know that you have solved this problem, and I will let you know whether the problem is correct or not. Okay, so thank you for watching this learning video and enjoy learning mathematics. Thank you.